And I would like to thank Cocoon to giving us this platform, this opportunity. Thank you so much, Cocoon. And a little bit of introduction. Okay. So, hello everyone again, and I'm Anjali Shukla. I'm Senior Security Consultant at Not So Secure with 4 years of experience in cloud security, CI/CD, infrastructure as a code, and DevSecOps. And I have delivered my talk earlier also at B-Sides Bangalore and Null Bangalore, and I have given the contribution towards Cloud Village and Black Hat. I also have a co-speaker whose name is Divyanshu Shukla, and he's having expertise in cloud security, bug bounty, and pentesting, and has been acknowledged by various organizations like AWS, Microsoft, and Apple. Divyanshu, can you please provide your introduction?
Thank you, Anjali. So I'm Divyanshu Shukla with over 6 years of experience, mostly into bug bounty pen testing. So currently I'm leading a cloud security team, and I do bug bounty, and I've been acknowledged by like Airbnb, and mostly I do pen test around the cloud. Like I have pen tested no AWS and GCP services and like WAF, and mostly the around the services, not around the misconfiguration. So other than that, I'm a trainer at Nullcon, B-Sides. I've given trainings on like cloud security and Kubernetes this year, and I'm also a AWS community builder. So over to you, Anjali. Thank you.
Thank you, Divyanshu. Next. Okay. So before starting, I would like to know that who all are aware with the serverless application? Anybody would like to share his or her insight? Anyone? Okay. No issues. So let's start. So today we will discuss about what are the serverless applications and what are its architectures, and how to persist your data within the serverless applications. What are the challenges we generally face while doing the Lambda pen testing, and what are the vulnerabilities that are recognized by the OWASP, like OWASP top 10 serverless, and followed by a demo and remediations. So let's start with the what is the serverless, or what is a function as a service. So serverless applications comes under the umbrella of function as a service. Function as a service is nothing, just another service, like we have segregations like software as a service, platform as a service. So function as a service says that you only have to, or the customer only have to come up with the code and hand over that code to the cloud provider, and rest everything will be taken care by the cloud. So rest everything means the infrastructure, the provisioning of the server, taking care of the configurations, load balancing, how the operating system will work, and everything. So we just have to worry about our code, and rest everything will be taken care by the cloud. Now, when we are using the serverless application, one thing is very important to note is that it is based on the trigger. So whenever there is a trigger A, the B will execute, or our code will execute. So here B is the serverless application. Trigger can be anything. Like if you're using if you have used any AWS service, then it can be based on your S3 bucket or any other services. So it's just the main concern is the trigger, that it is based on the invocation point or the trigger point. Next, as it is based on the triggers, and it runs for a very short period of time. So in AWS, we have maximum duration is 15 minutes. So your code will maximum run for the 15 minutes. And when it comes to its architecture, we have our application that is running into the containerized environment, and that containerized environment is present on the virtual machine. That virtual machine is again present on some base operating system, and that is entirely managed by the cloud provider. So you only have your code that you will take care, and as I mentioned earlier, like everything will be taken care by the cloud. And regarding the flow, so earlier I was mentioning that it based on the trigger. So whenever there is a trigger, your code will get executed. So we just have to upload our function onto the Lambda or any serverless services that are provided by the cloud, and based on the trigger, our code will execute it, or our cloud provider will run our code. So almost all cloud providers provide us the serverless application. In just the naming convention is different. So in AWS we call it a AWS Lambda. In Azure we have an Azure Functions, and in cloud we call it a Cloud Functions. And you can set the configuration, like I want my serverless application to use 500 MB of RAM, and it should have these environment variable, or I want to integrate the environment variable with another vault or secret manager kind of a service. So, and what are the IAM role, or what are the permission should be used by the Lambda. All the configuration I can set into my Lambda or the serverless environment. So when it comes to the persistence, I was mentioning that it runs for very short period of time. So in AWS, whenever it requests the trigger request, the whatever code you have mentioned or whatever code you have provided to the Lambda function, it will execute, it will upload it into the /var/task folder. So at the runtime or whenever there is a trigger request, this code will be uploaded into that directory, and that file system is completely read-only. Now, if you want or if Lambda require any write-only or the read-only permission, then it uses another directory, and that is a /temp directory. And this is the same concept we have in the Azure and the GCP environment. In Azure, we have the temp directory that is present into the D drive, and in the GCP also we have a /temp directory, and all these temp directories are writable. So whenever your code is executing, the code will be uploaded into the in some particular directory. It may be a var task or it may be a www root, but that is completely read-only file system. You cannot write on anything. So when it comes to its security sides, these are some surfaces that we can look into, or these are some components that we can look into. So let's start with the application. So you have an application running and it is having a CI interface. So you have to take care of that application, that security side, like what are the interactions, and if my application is having some application logic flaw or the runtime flaw, then it is connected with the API gateway. So whenever you want to expose your serverless application onto the public server, then you have to connect with some API endpoints. So for in AWS, we have an API gateway. In Azure also, we have an API endpoints. So the purpose is the same. I am exposing my serverless application into the public environment. So for that, so I have to look into the API gateway traffic flow also, like who all are able to access my API gateway. Then if I have a Python application and that is using a database in the background, so that, and both are present on the cloud. So application is a Python based and it is present in the serverless, but it is also using the database at the background. So I have to take care of its integration part security also, like how it is accessing the database, what are the IAM role that I have connected onto that, and along with the servers and the runtime environment that I have provided. So let's think about the attacker's point. So what does an attacker see? So as I was mentioning that there is an API gateway and that we have to connect with our serverless application whenever we want to expose our application onto the world or onto the public level. So whenever, like we generally do in pen testing, generally, and as an attacker perspective, we only get an endpoint, because that's everything is in the internal environment. What is external or what is available over the internet, or maybe in the source code or into the environment variable or some other configuration, we generally get an API endpoint. And so we have only this handful information, the API endpoint. So doing the pen testing of the serverless application or to the Lambda, it's quite very challenging. So I was mentioning its configuration of the important points while the serverless application, and that becomes the challenges too. So first is as we have only a one endpoint, that information we only have. And so second, as it is an event based and it is running for a very short period of time, so we are having that maximum of 15 minutes of that we have only that 15-minute segment to perform any to run any payload or any kind of a reverse shell or any look into that misconfiguration. So that period is very limited. Runtime environment on the operating system, everything is managed by the cloud, so we cannot, like, we have to look like how. Basically, it's very challenging as cloud is maintaining that, and we have very limited visibility into that. And then again, the configurations part. So these are the few challenges that we generally face while doing in Lambda pen testing. So OWASP says, so if you're not aware with the OWASP is an organization, and it is Open Web Application Security Project, the full format, and it generally takes care like what are the main vulnerability in terms of a web or in terms of a network or in terms of a serverless. So OWASP has recognized some vulnerabilities that are widely occurred. So it says that the first one is the injection. It can be of any kind of an injection. And then we have a broken authentication, XSS and XSC attack. Then we have some security controls, followed by the cross-site scripting, insecure deserialization, and vulnerability within the known components. And then we have an insufficient logging and monitoring. So instead of explaining each term, we will show you, we will present a demo before you, and there we have included all the vulnerabilities. So next, we have a Python-based application. So we have created a vulnerable Python application, and into that we have created some vulnerabilities like what will happen if there is an misconfigured IAM role, what will happen if there is an irregular DOS attack or the command injections or the excesses. So now I would request Divyanshu to present a demo regarding the same.
Thank you, Anjali. So first I'll show you guys the GitHub repo. I don't think, give me a sec. Yeah. So I don't have access to internet. Okay, it is not visible. Anyway, I'll show you then in the PPT. So this is the link. It's an open project written in Python. It's an extremely simple vulnerable application where you can just go and deploy it in any of your environment. Everything is mentioned. So I created this project because I was not aware that how to get started in deployment part of serverless. I knew how to pen test it. I'm aware of all kind of pen testing on the serverless, but I was not aware basically how developers work. Because once you find the issues, you have to sit with the developers, ask them like how to fix, or they want to know what are the fixes. So I wanted to understand their point of view before I start even like explaining them. So that's why I created extremely simplified version of application, and it also helps freshers and especially the teams who are not cloud oriented to understand how these issues will occur and why they will occur. Because we have a general idea that cloud is more secure. So what misconfigurations or insecurities will come, we'll talk about that, and I'll show you guys the demo. So most of the issues in the previous talks also, folks said that web app is the first entry point or initial foothold you'll get by exploiting the web app. So I don't think, just let me see if I can, because it's not sharing the screen, so just give me a second. I'll see if I can still, yeah, that's fine. So this is I have deployed this vulnerable web application, and here I don't think it's clearly visible, but this is the main page. It's a simplified application where you just have to enter the name, and it will reflect whatever you are entering. So I have for this demo, because it's just a 15-minute demo, so I've directly shown you the exploit. So you just enter the name, you see that the name is getting reflected back. So if we'll inject some payload like XSS payload or HTML payload, then it should work as well. So if I'm injecting a basic payload here, so I'll copy, like this is the payload. Image SRC, the most common kind of, one of the common kind of payload. So when I'm entering my name, it reflects welcome Divyanshu. And when I'll paste the XSS payload, it will trigger the alert based on the payload. You can inject any kind of payload and test. So it is not dependent on only XSS or HTML. Based on the application, it would work. Next is the SSRF. So I'll pause it here. SSRF is server-side request forgery. So when we forge a request or force a external server to send a request on our behalf as an attacker, when I'm exploiting this vulnerability, I can force the web servers, if they have this misconfiguration, to call other servers or internal applications or internal endpoints. Because those endpoints are internally available, and if I can force application, what I can do, I can read from those responses or endpoints which are only running on the local host or the internal IPs. So that's why this is very critical. And in cloud, there are multiple endpoints from which you can get data or metadata like 169.254.169.254. Where AWS generates temporary credentials, and if I can fetch those credentials, then I can configure those credentials on my local and later start the enumeration or exploitation of AWS itself. So similarly, in the case of Lambda, we don't have that endpoint, but we have an invocation endpoint. So in the invocation endpoint, what Anjali said, that the event will trigger the Lambda. So that event actually triggers this endpoint, which eventually triggers the Lambda. So if I know because this is an hard-coded endpoint, you will find it on the AWS docs. So because I know this is an endpoint, if my application is vulnerable to this SSRF, then I can enter this endpoint and I can try to figure out, I can do a denial of service, I can re-invoke the Lambda. So in Lambda, we have billing based on the invocations. So if my application is vulnerable to some kind of attack where I can continue re-invoking the same Lambda again and again. So I'll do that million of times. What will happen? Eventually, it will be a financial loss for the company. So attackers, they are not always motivated by data or getting inside the system. Sometimes they just do it for fun. And financial loss can be a reason, or a competition between the organizations. That can be another thing. So I'll show you guys the demo. So if you'll see here, so I'm using, by the way, HTTPI client, which is similar to curl or any binary. It helps to communicate with the APIs on a CLI. So I'm more of a CLI person, not a UI. So that is why I'm using this. So an endpoint is also present. If you guys want to try, you can try. I'll share that link after our demo. So if you'll see in this screen that we have an endpoint, then /dev. So this dev and stage and all these are the name of endpoints which you give in the API gateway. Then we have our regular application part. So if you'll see here, instead of calling some other URL which this application might be using, I am calling this internal URL. Because I know this is a path which is present in serverless. So when I'll invoke this path, let's see what happens. So if you'll see here, it is giving me like responses with all kind of IPs from where the request is coming, and like different values, variables. You can see like how the API gateway is configured. So in some cases, apart from this data, you will also see the environment variables which were injected in the runtime when that invocation happened. Because I am showing you a very small application, so the response is like having what I configured. But in reality, there will be much more data based on the application of, if it's the complete server running on the serverless, then you will have different kinds of environment variables as well. So this is just a small demo. That's why I'm just showing you the specific endpoints and path. Next is the command injection. So command injection is when I am able to run the Linux commands on any server. So because this serverless is also using Linux in the backend, and it is running on the containers. So because they are using the container, if my application is vulnerable to command injection or code execution, then in those cases, like especially we are here talking about the command injection. So I'll use this command. So let's see what happens when I'm passing this print env. So you will see these endpoints are little bit different on each of it, because like I try to create a API kind of a scenario where we can call different APIs. And when pen testing, you have to figure out these APIs, then only you can do the pen test. So if you'll see here, I'll do this print env, and you can see it is giving me access key and like S3 bucket name. So this is the response. First, I'll show you guys the response. So after running the command, it gives me 200 OK. And in the like body, it shows, you can see AWS session token. Next should be the access key and the secret key. So if I have these three variables, what I can do, I can copy them. I can configure it on my local and start the enumeration and start performing the attack. So if my serverless is extremely misconfigured in terms of permissions, like if I have attached admin role into this serverless, then what will happen? It will lead to complete takeover of your AWS environment. In some cases, it led to takeover of entire AWS organization when I was doing the pen test. Next is RE-DOS attack. So in serverless or in any application, we use regexes for multiple things, like validating the email or mobile number, or it can be anything based on that what developer requires. So there is a similar regex based issue which I have tried to show. So here the regex says that anything which starts with A and ends with B, like AB. So AB is it will match. If I'll mention A, then it won't match, because the string should it should end with B. So we'll try to send the valid request first, and then we'll see what happens. So RE-DOS is basically the use of causing denial of service using the regex, because regex takes some time and memory to parse these strings to match it, right? That is how the regex works. So if I'll enter a valid regex or the valid string which matches my regex, let's see what happens. So it gives me execution, the response time, it took some 10 millisecond or less than that, because my regex matched. Now if I'll send a very big string like around 1500 characters long, without, if you'll see the next payload, so if you'll see at the end, I haven't ended this at B. There is no B, only A string is there. So when I'll do copy and when I'll send it, let's see what happens. So if you'll see, my terminal is stuck at the bottom. And now it says internal server error, because the regex took some time to parse, and it kept on parsing because the string was very long, and it led to a denial of service. So it's a demo application, so like it restart itself, but in reality, if I'll keep on doing like 1000 times for your application, what will happen? Your billing will increase, and eventually your server or your application might stop working. So like users will start facing issues, right? So this is one way of easy way of showing and exploiting how to perform the regex attacks. So you have to figure out where the regexes are used. You have to test it on the, maybe a mobile number or on emails or anywhere like where you could possibly think the developer will use the regex. Next is the serialization and deserialization. So basically it's a deserialization RC. So whenever the data is stored on the disk, in a format like when it is converted into an object, in Python we use pickle, and when the same data is reconstructed and sent across the channel, it is deserialization. So because we are using Python pickle, which is vulnerable to this deserialization RC, so when this data which is saved in the object form, right, it is reconstructed back, it uses some system calls which led to the execution of arbitrary code. So I'll show you like how a serialization looks like, and my code is deserializing the same thing. So I'll do serialization here. So I'll explain the code as well very quickly. So it's Python 3, and then I'm importing the library pickle base64 to encode this value into the base64 format. Then I'm just passing the object. This is my payload or any random value which I want to save. Next is I'll use pickle.dump, and I'll convert whatever I'm getting into a base64 encoded format, and then I'll print it. So I'll copy this and I'll paste in my terminal. So you'll see once I do print base64 data, it prints a base64 data of this A1 and B2. So after that, I'll test with a valid payload to see how my application is working in reality. So when I'll send the same payload, it says pickled successfully. So that means my application is working extremely fine. Then I'll create a Python code. So here, if you'll see, it takes the same endpoint and it imports some libraries, and then the attack point. So this is my application where the deserialization is happening, and as an attacker I am aware it can be anywhere in the cookies or like such fields where data is stored on the disk. So usually by repeated pen test and like application knowledge, you will figure out that okay, the deserialization is happening. And the next is I'm passing the argument and I'm running the command in the bottom, touch/tmp/hacked. So we know that temp is the directory which is available, and it is writable, right? So that is why we'll use this directory. And then I am using the pickle, and the same I am converting everything, but this time I am passing a payload which will lead to a command execution. So I'll use this cat EOF format. This is used to create the file in Linux using the cat command. And then once it is executed or my Python script ran successfully, I'll test whether the file is created or not, because I want to validate whether my code was executed. So that if this is just the demo, so in reality I'll try to take a reverse shell, maybe I'll try to do a print env command, or I will try to find that access key and secret key. I'll try to find the requirement.txt or .json or toml or any kind of file like pom.xml based on the application, that what are the dependencies dependencies, then I can move forward in scanning those dependencies. Maybe I can find a dependency which is vulnerable if actual application is not. So it will depend, like I'll try to enumerate the no errors via information disclosure. I try to send the random strings. So those who use serverless, like this is the most common scenario you will find. By entering a garbage string or very long string, you can introduce the error which will show the stack endpoint and the kind of data or kind of code you are using. So if it is a Python, it will show the Python error. If it is an JS based application, it will show that kind of error. So this is very common when I start testing. That is the first payload I'll try. I'll enter a garbage value, special characters, and it will initially show that the error stack trace error. So please make sure to handle those kind of edge cases. And once I send the validation request that whether the file was created, because it's a command injection, so it shows that like the file was created with the name of sbx_user. So this is the user by which my Lambda is running. And at the bottom, if you will see, the temp hacked was created. So this is pretty much it about the Lambda pen testing demo. Now we'll talk about the defense. So let me move my screen back. Where is my cursor? I think I've lost it. So next is the defense and monitoring in AWS serverless. So till now we talked about that we can protect it, but we don't know how to get inside. There is no way we can get inside a server where we can't access anything, or we don't know what is running inside that. So we actually don't know there, right? We can't log in, we can't do SSH, so how to protect or what to do? So in these cases, you have to use AWS native service, especially in the case of AWS, Amazon Guard Duty. You can enable this Guard Duty, and it will detect the real-time issues which might be present in your vulnerable serverless, or if someone is trying to attack, maybe if someone is trying to steal the access key and the secret key, your Guard Duty will trigger, and you can integrate Guard Duty with the Slack to get the real-time alerts. Next is the logging and audit. So you can use CloudTrail for getting the logs. So when I started creating this application, CloudTrail was the place where I'll go and I'll see whether my Lambda ran successfully, because I don't know that much of coding. So I did not create a function where it logs everything and sends it to a S3 bucket, because I can't store it locally. I don't have access to that local file. So either I have to store it in the S3 or somewhere else. So as a test application, I don't want my bill to increase, right? So that is why you can go to CloudTrail and check there, like what kind of invocations are happening, whether an error is coming or not. Next is an AWS X-ray, which is also used to monitor the serverless. You can very easily integrate it. Next is the scalability and concurrency. So at a time, right now we are just dealing with one application. But if we are dealing with a complete server, you can set how many parallel containers you want to start. Along with that, you can also set how many containers should run at any point of time, so that your billing is under your finances. Next is the API gateway security, because we talked about serverless and it is connected to an API gateway. So there is a serverless endpoint also which you can use for regular testing, but you can't attach WAF and any kind of solution there. So if you want to do routing, or if you want to add the WAF or web application firewall, then you can use this API gateway for the routing purpose. If you remember from the demo, there was a proxy plus path. So that is the routing which I have configured. So any endpoint when I'll add, it will automatically send it to that route path itself. So you can use API gateway to protect your applications. Next is the CSPM solutions. So there are open source CSPM solutions as well as the paid, which you can use to integrate with your serverless. And there are other monitoring tools also which you can connect for the login monitoring. I won't name them. But you can search on the internet and you will find plenty of tools. And last is enable billing alerts for the Lambda. That is the most important thing, because as an attacker, when I'm trying to pen test, it is not always about finding vulnerabilities. Sometimes I just want to learn. Like right now, we all learned that there is something called as Lambda. So now if I want to do pen test, what I'll do? I'll try to find a Lambda. I'll do a Google Doc and search on the Google, and maybe I'll try to test it. So what will happen? The invocations will happen on your Lambda, and you don't know who is exploiting or why someone is testing. Because as for me, as a pen tester, I want to learn, right? Any malicious threat actor, insider or outsider can test these scenarios. I'm just giving an example. So in those cases, if you have billing enabled, you can easily get to know that, okay, my billing is increasing for that Lambda. Is there any attack happening? So these are some common ways by which you can detect what is happening in the Lambda. So next we'll talk about the remediations. So remediations are extremely simplified and based on what we do on the web applications or the OS top 10 web application remediation. So for the injections like SQL injection, so in that case you can use prepared statement. For XSS you can use sanitization. So in the serverless OS top 10, XSS is different, so that is why there its remediation is presented in the next page. Next is the broken authentication. So you can use AWS Cognito for managing the session and authentication, which is an native AWS service. So next is sensitive data exposure. So you saw, right, that I was able to get inside the serverless, or I was able to execute the command. I also told you guys that I can invoke errors. So based on those things, if there is some sensitive variable or environment variable, it would be exposed. So you can take care of that. Maybe you can use AWS KMS or Hashicorp or Vault for integrating it with the your application. Next is XML, external entity attack. So it is a attack which happens on the applications which uses XML. So XXC basically uses DTD. I won't be going into detail, but it expands that XML tag. So it's similar to HTML, but the expansion happens. It basically reads line by line, it interprets it, and whatever is mentioned, so suppose it is mentioned file, so it will try to fetch that file. And because of that, if instead of passing the internal file, attacker can control that payload. It will ask, like it can force the application to read etc pass WD or shadow. So it is, you can use the parser or you can disable the DTD or the expansion itself, so that your application is not vulnerable to XML entity attacks. Next is the broken access control. So it is similar to authentication, but in authentication we are just checking whether any user can access my application, or any user who what they say are accessing. And in the authorization we talk about the principle. So here another thing would come is that if my serverless requires access to S3 bucket, then we should only give access to that S3 bucket instead of giving entire permission or giving the permission of star, right? So that entire AWS or all the services are accessible. So you have to make sure you are completely authorizing your serverless, plus you have authorization of the users who are logging or registering. Next is the security misconfigurations. So this will come under the AWS misconfigurations, that any kind of AWS misconfiguration, like if your serverless using a DB and it is unencrypted. So in case of attack or breach, it is possible for attacker to leak that data or steal that data. So do not perform these kind of, or do not leave your environment misconfigured. So you can use CSPM tools, open source tools. In the previous session also, before us, there were a couple of CSPM showed. So you can use them to scan, you can perform the vulnerability scanning or misconfiguration scanning for the cloud. And based on that, you can at least fix the critical and high for the beginning. And then you can move towards the medium and low. And next is the cross-site scripting. So it's where the JS or HTML payload is reflecting back onto the browser. So it leads to client-side attacks more often. In some cases, it also leads to server-side attacks, like where server-side React kind of JS are used. But mostly it is the client-side issue where you inject something and it is reflected back onto the browser. Next is insecure deserialization. So we already saw that. And to prevent it, do not use libraries like Pickle, instead use JSON. So if you are using YAML, load it as safe YAML. So these kind of some things which is specific to Python, because I know Python, those who are into Java or any other language, they can search and they'll get documentation in the OWASP website itself. Next is using components with the known vulnerabilities. So if I'm using Pickle, right, or if I'm using any specific base64 library I was using, so if that library itself is vulnerable, in that case, when my application is using that library, it would be vulnerable as well. Like log4j is a very common example across the industry right now. Because if my library is using log4j, immediately my application would be, or my serverless application would be vulnerable as well. Next is insufficient logging monitoring. Because we can't get inside the serverless or the container running, I can't go and install any endpoint security. So instead of that, you can use these native solutions like CloudTrail or X-Ray and have this real-time alerting. So that is pretty much it on the remediation part. So this is a serverless mind map which I have created. So I'll upload this. It might not be visible here. So I'll upload this on my LinkedIn and Drive, and I'll share it, and from there you can look into that. So these are some common attacks. So it was not possible for me to show all the attacks. So that is why I've created this, so that those who are like completely new, they can directly learn about these. So it also includes the source code review or the static code review for your serverless applications, because anyway the developers will be writing the code. So always perform the static source code analysis. So, and this is the live lab which is running. It is the same lab. So it won't be running for long, like after 15, 20 minutes or 30 minutes, I'll close. So if you guys want to log in and see, you can check, you just have to open it. So that is pretty much it.